Hi students, today we will learn umpolung, that is reverse of polarity, using epoxide as an umpolung. Epoxides is a cyclic ether. Epoxide, that is oxirane, as an umpolung reagent is used in 1,2 difunctional compounds. Let us look at the synthesis and also the retrosynthesis and the corresponding synthesis. So first one, target molecule 1, you can see that the numbering. The hydroxyl carbon is numbered 1 and the adjacent carbon to the left side is number 2, and the next to the carbon 2 is the oxygen. So hence we can do the 1,2 disconnection. So this we have already studied, that is the nothing but a type of CX disconnection, wherein in the CX disconnection it is a type of 1,2 disconnection, because the oxygen is because we're disconnecting the C2 and the oxygen. So after disconnecting we are going to obtain the two synthons. One is the oxygen anion, that is the anion and the cation. Now when you look at the anion, because oxygen is highly electronegative, it is getting the negative charge. And when you look at this cation synthon, so here you can see that the carbon atom which was attached to the OH is getting the positive charge, and the second carbon is to be getting the negative charge, right? But here what happens is, since we are using the umpolung approach here, what happens is the second carbon obtains the positive charge. So whenever there's a change in the polarity, we call it as the umpolung synthon, and using the reverse of polarity is being used for this kind of example. Now correspondingly, now why we are using the positive charge for the carbon 2 is because there is a trick behind this kind of synthesis. See, whenever we get a positive charge on the second carbon, and when there is a hydroxyl group which is attached to C1, then definitely the synthetic reagent can be the formation of an epoxide. And epoxides, we know that they can be easily used for the synthesis, wherein we can get the hydroxyl as the target molecule. So hence whenever we have this opportunity, always you have to give a positive charge to the carbon atom which is in the position 2 of the hydroxyl group. When we do in such a kind of a method, then we can get the epoxide as the umpolung reagent. So now when we give the positive charge to the carbon 2, then we are going to write down these two are the synthons. Now we will write down the synthetic equivalents. The synthetic equivalents for the anion is getting a hydroxyl, is getting a proton to the O minus attacking to the proton, which gives the hydroxyl, and the second cation synthetic reagent is going to be the umpolung reagent, wherein the oxygen is going to attack the electrophile, that is the carbocation, which forms the epoxide. That is the cyclic ether is going to be obtained. So now this is the umpolung reagent. Now let us see how this can be used in the formation or in the synthesis. So now here we know that the hydroxyl group which is attached to oxygen is always highly acidic. So hence when we use any base, even a mild base can always deprotonate the hydroxyl group. So now here we are using the methoxide anion. So here what happens is it is going to abstract the proton of the OH group. When it abstracts, we are going to get the oxygen anion. When we get the oxygen anion, this anion is a nucleophile. So this nucleophile can attack the epoxide, that is, it can attack the carbon which is attached to the oxygen. So now the carbon attached to oxygen is going to be electrophilic. So hence the O minus is going to attack the C plus carbon. So when it attacks, there is going to be the ring opening. So at this ring opening junction, it is said that there is the epoxide which is used as the umpolung at this position, wherever there is the ring opening of the epoxide. Now when there is the ring opening of the epoxide, we get O minus. So that is a bond is created now between oxygen and the carbon, and then we can just go on writing down the substrate, that is the intermediate, and once it is written, we know that the oxygen now gets the negative charge. When the oxygen gets the negative charge, so here the oxygen gets the negative charge, and now this O minus again reacts with a proton to obtain the target molecule. So now this is the kind of the reaction wherein we use epoxide as the umpolung. So here whenever you get this kind of an reagent or a synthon, then always make make use of the epoxide as writing down the umpolung reagent, which will be easier for writing down the synthesis. Now let us go with the second example. So now in the target molecule 2, here again we have a CX disconnection. See, now you can see that numbering, hydroxyl carbon getting 1 and the carbon 2 is getting the adjacent carbon getting the carbon 2 position numbering. Now there is a disconnection between the C2 and the N. So this is again an example for CX disconnection, wherein we are disconnecting between the carbon 2 and the nitrogen. And above the retrosynthetic arrow, we will write down as 1,2-DIX. So di in small letter and x in the capital letter, showing that it is 1,2 disconnection. Now after disconnecting, we are going to write down the synthons. Now the synthons is going to be the cation and the anion. Now here again we are going to make use of the umpolung synthon. So here again you have a hydroxyl group in the target molecule, and all the criteria is suiting. That see here we have a hydroxyl group in the target molecule, and we are disconnecting between. We're doing the 1,2 disconnection. So when we do 1,2 disconnection, then obviously we can make use of a umpolung synthon. So this is how you can analyze the target molecule and write down the synthon and the retrosynthesis accordingly. So whenever there's a hydroxyl group and whenever there is 1,2 disconnection, you can make use of the writing down epoxide as the synthetic equivalent. Now here again, the hydroxyl carbon, the carbon bearing the hydroxyl group is going to have the positive charge, and the next carbon would have had the negative charge, that is the carbon number 2. But here since we are making use of the umpolung reagent and the umpolung process, so that carbon is going to get a positive charge. Now once we write the positive charge, so this is going to behave as a umpolung synthon, and since nitrogen is highly electronegative than carbon, this is the anion, that is the nitrogen possessing a negative charge. Now this we are finished writing the synthons. Now let us write the synthetic equivalent. Now the synthetic equivalents for the umpolung synthon is going to be an epoxide, because it is following the same method. Oxygen is nucleophile, is going to attack the electrophilic carbon and forms a ring. That is a ring. That is a 3-membered ring with an ether in it. So it is going to form an epoxide, and the NH minus is going to abstract a proton to give the amine. So now this is it about the synthons, synthetic reagents. Now let us write the synthesis. Now here the synthesis we know is that nitrogen is an electrophile, having a having a lone pair, so it is going to attack the carbon, electrophilic carbon, and then there is a ring opening. So when the ring opening is done, we are going to get an intermediate of this kind, wherein the nitrogen now is having 3 bonds, so hence possesses a positive charge, and O is having a negative charge. Now this O minus takes up the proton from the base to give the it's going to take the proton from the NH2. The O minus is going to take the proton from the NH2. So it is going to give rise to the target molecule, wherein there is nitrogen is having a 3 bonds and it is satisfied, and here there's no negative or positive charge, and hydroxyl is formed. So this is the target molecule which we are getting after the synthesis. Now we have another molecule, that is the target molecule 3. So here you can again see there is an dice function group, that's the ketone and the hydroxyl. So see, all these kinds of epoxides can be used for the synthesis of 1,2 and 1,4. So that is very much clear with all these examples given here. Now this is again an 1,2 CC disconnection. So here what happens is, once you start numbering, you can either number what the way I have written, that is the ketone carbon getting 1, 2, 3, 4, that is the carbon on the hydroxyl obtains the carbon 4, or you can also go the reverse way, wherein the carbon hydroxyl carbon gets 1 and 2 is numbered for 3 and 3 is numbered for 2 and so on. So here again it is an example for 1, 2 CC disconnection. So if you number hydroxyl as 1 and the subsequent as the 2, then it is after the carbon we are going to disconnect. So it is a 1, 2 CC disconnection. So after disconnecting, we are going to write down the synthons. So the synthons is going to be the anion and the cation. So here again you can see that we are making use, see here there is a hydroxyl, and here again it is suitable for the 1, 2 disconnection. So whenever you get a synthon like this, then always make sure that you're writing it as an umpolung synthon, wherein the carbon 2 gets the positive charge. So only when the carbon 2 gets positive charge, which we are going against the natural polarity, that's when we write down as the umpolung. And when this carbon 2 gets the positive charge, only then we can get a epoxide, which we can write down as the synthetic equivalent. There is a reagent, umpolung reagent. So from the umpolung synthon, we are going to get the umpolung reagent. Now this umpolung reagent and the acetaldehyde, this is what we are going to make use of in the synthesis. So we have a base which is going to abstract the hydrogen of the hydroxyl, making it a oxygen, making it a carbanion. And here this nucleophile is going to attack the carbon of the epoxide. Sorry. Is going to attack the carbon of the epoxide. Then after after attack of the carbon on the epoxide, there is going to be the ring opening wherein the oxygen gets the negative charge. Now this negative charge can be neutralized when it abstracts a proton from the base. When it abstracts the proton from the base, we are going to get the target molecule 3. So this is again making use of the epoxide as the umpolung. So this is an example 3 with the ketone and hydroxyl as the functional group. Next, let us go with the example 4. So now here in the target molecule 4, we have a diketone, we have an ether, we have a carboxylic acid, we have diketone, and we have a hydroxyl group. So here you can, this is again an example for 1,4 difunctional disconnections. So here we have the ketone, which is we have numbered as 1, and 2, 3, 4 goes for the hydroxyl carbon. And you can, if you start numbering from this end also, again hydroxyl is getting the carbon number 4. So again this is an example for 1 and 4 difunctional disconnections. So here again you can make use of 1, 2 CC disconnection. See here, let us again take hydroxyl as the group. You can either number it from the ketone or you can number it from the hydroxyl. But whatever you are numbering, make sure that you're writing down the what kind of disconnection you should write down above the retrosynthetic arrow, so that it will be clear for you to note down where you are disconnecting the target molecule. So here we are, if you number hydroxyl carbon as 1 and the carbon number 3 as carbon number 2 in, with respect to hydroxyl nomenclature, that is numbering. So here you are going to disconnect between C2 and C3. So the disconnection is going to be between C2 and C3, and hence we can again write down as 1,2 CC disconnection with respect to the hydroxyl. We're going to do the 1,2 CC disconnection. So after writing down the disconnection and writing down the retrosynthetic arrow, let's go ahead with the synthons. So the synthons is going to be a anion and a cation. So here we are again making use of the umpolung synthon. See here we have the hydroxyl group, and the carbon number 1 is going to have the positive charge because oxygen is highly electronegative. Now the subsequent carbon is going to be obtained a negative charge according to the normal polarity or a natural way of assigning the polarity. But here we are making use of umpolung synthon, and hence this carbon number 2 bears the positive charge. Now when this kind of an approach we are getting, it is suitable for us to write down the epoxide as the reagent. That's because, so if we have a negative charge, then we definitely cannot make use of epoxide as an umpolung reagent. So hence we have to give a positive charge or a positive polarity for the carbon number 2. Only then we can write down as only then we can write down the epoxide as an umpolung reagent. So now when we give this kind of an approach is obtained as a synthon, at this moment we can write down as epoxide as the reagent. So now we get both the synthetic reagents, and now let us write down the synthesis. Now again we have the carbon, central carbon, that is the carbon having a hydrogen bonds. There are 2 hydrogen bonds to the carbon, and both the hydrogens are highly acidic. Hence we can make use of a weak base also like sodium hydroxide, and it can abstract the proton, leaving a carbanion on the carbon. So now when there's a carbanion, this carbanion can again attack the carbon wherein there is a ring opening of the epoxide. So we are not going to attack the carbon on the more hindered side. We're going to attack, there's going to be attack on the carbanion on the less hindered part of the carbon. So once there is an attack of the nucleophile on the electrophilic carbon, then there's a ring opening to give an O-. Oxygen anion is formed as the intermediate. Now this oxygen anion can attack the protonation of the oxygen anion is going to give rise to the hydroxyl group, and this is what we are going to obtain as the target molecule. That is, we have written down the synthesis of the target molecule. So this is the examples for epoxides and as an umpolung reagent. This you can make use of this concept in synthesizing, writing down the retrosynthesis of a highly complex aromatic compound or any other compound which is given to you. And this can also be written as a separate entity, wherein it can be asked for a 2 marks questions also, or it can be a part of a retrosynthetic analysis of an aromatic compound. So this is it for today, students, as this is the second kind of first kind of the reagent which we are using in the umpolung, that is the epoxide. So in the future classes I will be explaining, taking other examples as the umpolung reagents. Thank you very much.